Hello friends, welcome to Maths Practice. Today we are going to start with the chapter Coordinate Geometry from class 10. In the first part we will discuss the distance formula and all the very important examples based on the distance formula. So watch the video till the end and do subscribe to Maths Practice. Some important concepts. The distance of a point from the y-axis is called its x-coordinate or the abscissa. That means your x-coordinate is also called abscissa. Similarly, the distance of a point from the x-axis is called its y-coordinate or another name is ordinate. So x-coordinate can be called as abscissa and y-coordinate can be called as ordinate. Any point in the xy plane will have the points in the form of xy. Any point on the x-axis will be of the form x0 because on x-axis the y value will be 0. Similarly, any point on y-axis will be of the form 0y. Distance between two points P, first point which has coordinates x1 and 0 and Q, x2, 0 on the x-axis is given by PQ, which is the absolute value of x1 minus x2. Why absolute value? Because you know distance cannot be negative. So distance between two points which are on the x-axis will be x1 minus x2. Similarly, distance between two points A 0 y1 and B 0 y2 on the y-axis is given by absolute value of y1 minus y2. Now the distance between two points A x1 y1 and B x2 y2 is denoted by AB or small d and it is given by the square root of x2 minus x1 whole square plus y2 minus y1 whole square. This is a very important formula used in most of the examples. Now some important concepts regarding the distance formula. The distance between two points is always a non-negative real number. That means distance between AB is always greater than or equal to 0. It is very clear distance cannot be negative. Distance between A and B is 0 if and only if A and B are the same points. Distance between A and B is same as distance between B and A, means AB is equal to BA. That is very clear from the formula because under root of x2 minus x1 whole square plus y2 minus y1 whole square is same as under root of x1 minus x2 whole square plus y1 minus y2 whole square, because when you square it will be the same. So distance between A and B or distance between B and A, it is the same thing. If A x1 y1 B x2 y2 and C x3 y3 are 3 points in the coordinate plane, then distance between A and B plus distance between B and C is always greater than or equal to distance between A and C, or AB plus BC is always greater than or equal to AC. If the 3 points in the above case, if 3 points are given and the 3 points are collinear, that means they are in the same line. Collinear means they are in the same line, then AB plus BC will be exactly equal to AC. And suppose if they are non-collinear, then AB plus BC will be greater than AC. The distance of a point PXY from the origin, obviously when you put first one point is XY, second point is 0, 0. So when you put in the distance formula, the distance of any point from the origin will be equal to square root of x square plus y square. Now some examples based on the distance formula. Remember, these type of examples are frequently asked in exam. First example, simple one, find the distance between 2, 3 and minus 3, minus 9. 2 points are given. So over here x1 is 2, y1 is 3, x2 is minus 3 and y2 is minus 9. Distance between AB, 2 points A and B is AB square is equal to x2 minus x1 whole square plus y2 minus y1 whole square, which gives us 169. So AB is square root of 169 or 13. Example 2. Determine if the points P, Q and R given over here are collinear. Now, first of all, we will find the distance between P and Q, Q and R and P and R. PQ square, again we get PQ square as 10, which gives PQ is equal to root 10. By using distance formula, we get QR square as 40. So square root of 40 is square root of 4 into 10 or 2 root 10. Similarly, PR square is equal to 10. So PR is root 10. So now from the above values, we can say that PQ plus PR is equal to QR. So the 3 points are collinear. Now, since PQ plus PR is equal to QR, it is very clear over here that P is between Q and R. Example 3. Prove that P14, Q41 and R44 are the vertices of an isosceles triangle, and also show that triangle PQR is a right angle triangle. Now we are given 3 points which are vertices of a triangle. To show isosceles triangle, we have to show any two sides are equal. So by the distance formula, PQ square will be x2 minus x1 whole square plus y2 minus y1 whole square. Putting the values, we get PQ square as 18. Similarly, QR square as 9 and PR square as 9. Now this shows that QR and PR are root 9, which is 3. Means the two sides are equal. So it is an isosceles triangle. Now to show it is a right angle triangle, we can use the converse of Pythagoras theorem. So if the sum of squares of two sides is equal to the third side, then the angle opposite to that third side is equal to a right angle. Over here it is very clear, PR square plus QR square is 18, which is equal to PQ square. So it is a right angle triangle. Now the right angle is at R. Why? PR square plus RQ square. Remember, for distance formula, QR square or RQ square is same, because x2 minus x1 whole square is same as x1 minus x2 whole square. Distance is always positive, or you can say it is always non-negative. So we have PR square plus RQ square is equal to PQ square. So it is a right angle triangle with the right angle at R. Example 4. If the distance between the points P32 and Q7K is 5, find the value of K. Now it is given PQ is 5 or PQ square is 25. By distance formula, x2 minus x1 whole square plus y2 minus y1 whole square. That means 7 minus 3 square plus k minus 2 whole square. That is equal to 25. It is given. So now we just have to simplify this quadratic equation. So after factorizing it, we get k minus 5 into k plus 1 is 0. So k is either 5 or k is either minus 1. Friends, we are discussing examples which are generally asked in the exams. So now the example 5. Find a point on y-axis which is equidistant from points P32 and Q minus 1 minus 5. Now we have to find a point which is on the y-axis. So we have seen before that a point on the y-axis will have its x coordinate always 0. So let that point be A. So the coordinates of A can be 0 and some y. Now it is given that the point is equidistant from another 2 points P and Q. That means AP square and AQ square are same. So now just we have to use the distance formula. So we get 3 minus 0 whole square plus 2 minus y whole square is equal to minus 1 minus 0 whole square plus minus 5 minus y whole square. Just we simplify this equation. So we get the value of y as minus 13 by 14. So our required point on the y-axis is 0 minus 13 by 14. Example 6. Show that A 310, B 65, C 12 and D minus 27 are the vertices of a square. Now you have studied regarding quadrilaterals. To show it is a square, you can show it is a square by two ways. First way is show that all four sides are equal and both diagonals are equal. Second way is show that all the four sides are equal and one of the angle is a right angle. So if one is a right angle or four sides are equal, so it will be a square. All angles will be right angle. Now by the distance formula, first of all, we will find the distance between the points. So you have the square ABCD. So we find AB square, BC square, CD square and DA square using the distance formula. So this is very simple. So we first find the squares AB square, BC square, CD square and DA square. Now suppose if we use the first way, then it is very clear over here that AC square, that first of all the four sides are equal. That condition is satisfied. Now for the diagonals AC square and BD square, both the diagonals are also equal. So hence AB is equal to BC is equal to CD is equal to DA, and diagonals AC and BD are same. So by the first way it is a square. Or suppose if you want to use the second way, then four sides are equal, that is very clear. And by the converse of Pythagoras theorem, AB square plus BC square is equal to AC square over here. That means angle B is a right angle. So if one of the angles is a right angle, all four sides are equal, then also it is a square. So you can use any one method to show it is a square. Now example 7. If the center of the circle is 2a, a minus 7, then find the values of a if the circle passes through the point 11 minus 9 and has a diameter of 10 root 2. Now see over here, we have to find the coordinates of the center of the circle, means we have to find the value of a. Center is suppose C, which has coordinates 2a, a minus 7, and if the circle passes through the point P, which are coordinates 11 and minus 9, then we know that the distance between the center and that point, means CP, will be equal to the radius of the circle. So radius is equal to CP using the distance formula, root of x2 minus x1 whole square plus y2 minus y1 whole square. So we get the radius CP as over here. Now it is also given that diameter is 10 root 2. That means radius is 10 root 2 by 2 or 5 root 2. So we have got two equations for radius. When we just equate both of them, we get 5a square minus 40a plus 125 is equal to 50. We square both the sides to make the calculation easy. So on simplifying this quadratic equation, we get the value of a as 3 and 5. Hence the required values of a are 3 and 5. Now some assignment examples. See, we have discussed all the different types of examples. Based on that, I have given some assignment examples. You can solve them. Answer is given. If there is any query, you can write in the comment section. First one is find the center of the circle passing through the points 6 minus 6, 3 minus 7 and 3, 3. Just now we have seen an example which is of this type. The answer is center coordinates are 3 minus 2. Prove that the points A, B, C, D given over here are vertices of a rectangle. We have shown for the square. For rectangle, what is the property? Just show that opposite sides are equal and the diagonals are equal. Third, find a point on x-axis which is equidistant from the points minus 1, 2 and 5, 4. We have done a similar example for a point on y-axis. Now since it is a point on x-axis, coordinates will be some x and 0. The answer is 3, 0. Show that the points 2, 3, 2, 5, 2 plus root 3, 4 are vertices of an equilateral triangle. This is also simple. Equilateral triangle, show that all the three sides are equal. Example 5. Show that A, B and C given over here are collinear. So if the sum of the distance between 2 points and the third one is same, then we can say that the points are collinear. Friends, in this video we have seen the very important distance formula and all different types of examples which can be asked in the exam, which are based on the distance formula. In the next video, we are going to see another important formula which is called the section formula and all the examples which are based on this. So, if you understand these examples, then there will be no problem in answering the exam. Please do like and share this video and subscribe to my channel Maths Practice. Thank you.